So heavy, and all there is like.
So again, today's essential question is, what is the square root of a negative number? Because the square root of a negative number, if most of you guys have calculators in front of you, if you type in the square root of a negative number, can anybody tell me what you get? What does it say after it says error?
Unreal.
Non-real. If something isn't real, what do you think it is? This it doesn't have to do with math. Like in real life, if I say that's not real, it's, what's another word for fake? Okay, what's another word for like something we make up in our mind? Imaginary. So today, the square root of a negative number is going to be imaginary. It's non-real. So hopefully when you get that error message and you're trying to find reduced square roots, or sorry, square roots in general of a negative number, and you see that error message that says non-real, it triggers you to remember that it's imaginary. So we're going to skip around on the notes a little bit. So I would like for you to flip over to example number 5. And we're going to simplify some square roots first. So it says right at the top, complex numbers. The square root of a negative number is a complex or imaginary number, and we use the symbol I. So I stands for imaginary. So this is written up at the top. Complex numbers, the square root of a negative number is a complex or imaginary number. And that's why we use the symbol I, imaginary symbol I. But other square roots just reduce the way that you think they do. So what is the square root of 4? 2. So if you have the square root of negative 4, then the answer is 2i. It's imaginary. So this becomes 2i because it's imaginary. So anytime you have a negative number, it's going to have an I in the answer. Sorry, square root of a negative number. Next, square root of 50. And if you're looking at your perfect squares chart, 50 is not there because nothing times itself equals 50. But square root of 50 is a very common square root and it can actually reduce. So if you look down the perfect squares chart, is there a number or a perfect square that can divide into 50? 10 or 5, neither one of those are perfect squares. So remember, a perfect square is 4, 16, 9, 25, 49, 36. Those are all perfect squares. And so Nathaniel told us a perfect square that can divide into 50 is 25. So what I'm going to do, and I'm going to work really slowly, I'm going to show you step by step. The square root of 50 is the same thing as the square root of 25 times 2. 25, that's the same thing as 5 squared times 2. Anytime, and there's actually this little imaginary 2 right here. It's called an index to make this a square root. You can also have a cube root, and right here there would be a little 3. So anytime that this index matches an exponent, it actually cancels out. So the square root of something squared, so this square piece cancels, and then out in the front becomes a 5. So I'm going to rewrite this. It becomes 5 square root 2. So that's how you reduce 50. So sorry, square root of 50. You have to find perfect squares that can divide into 50. So here, when I have negative 50, it's going to reduce exactly the same. So I'm going to skip a step and say that this is the same thing as negative 5 squared times 2, because 5 times 5 is 25. And I'm going to cancel out this square piece, and I'm going to bring out the negative 5, but it's going to come out as 5i, because the square root of a negative number is imaginary. So I get 5i square root 2. So anytime you have the square root of a negative number, out in the front is going to become an I. The square root of 45, that's another very common square root that you're going to have to reduce. And so if you keep up with these notes, once we already reduce this, you don't have to show me the work to reduce it. Like you can look at this chart and go, oh, okay, I have the square root of 50. Well, the square root of 50 is 5 square root 2. Square root of 45. Can anybody find a perfect square that's going to divide into 45? Jaden was really quick with that. It's 9. So 45 is the same thing as 9 times what? 5. Well, 9 is the same thing as 3 squared times 5. And anytime you have something squared in a square root, they cancel out operations. And out in the front comes a 3. So I end up with 3 square root 5. That's a very common square root. The square root of 45 is 3 square root 5. So what do you think that the square root of negative 45 is going to be? 3i square root 5. So I don't have to go through these same steps. And I is going to come out into the front. So I'm going to get 3i square root 5. So on your homework, this matches with questions 13 through 16. So 13 through 16, you're reducing square roots. One of them is just a perfect square, so it just reduces really quickly. But these are also some common square roots. And the reason we need to know how to reduce square roots is because we're going to have answers with square roots. And sometimes they don't reduce. The square root of 13, it doesn't reduce. You would have an answer and it has the square root of 13. Your answer is just square root 13. And sometimes they do reduce. Sometimes you get square root of 50 and we need to rewrite that. And we need to rewrite it as 5 square root 2. So we needed to brush up on reducing square roots and reducing negative roots. All right, now we're going back to the front. So back to the front. We're going to solve some problems solving with square roots. So solving with square roots. And this is a quadratic. When we solve with square roots, first thing I'm going to do is try and undo something that is squared. And to undo something that is squared, I can take the square root of both sides. One thing that we have to do is that when we introduce a square root to the problem, we have to acknowledge the positive and negative root. So anytime that we take the square root, we have to do plus and minus the square root, plus and minus the square root of both sides. So when we take the square root of a square, they're opposite operations like addition, subtraction. Squaring and square rooting, they're inverse operations. They undo each other. And so on the left side, this actually disappears so that I am left with x plus 6. I just undid squaring that side. On the right side, I am doing plus and minus the square root of 4. Well, what is the square root of 4? 2. So I end up with plus and minus 2. And sometimes it works out like that we just get a value. Sometimes it works out that you get a square root and it doesn't reduce. But if it does, now all I need to do, what would I do to get x by itself? Subtract 6. Okay, but I'm going to have two different branches now because I've got plus and minus 2. So I'm going to have to subtract 6, but I'm going to have to split it into two different problems. I have x plus 6 equals negative 2 and x plus 6 equals positive 2. And it doesn't matter if you put positive and then negative. Doesn't really matter. And y'all already told me that to get x by itself, I would have to subtract 6. And so I've got these two different branches, and I get x is equal to, what's negative 2 minus 6? I'm getting more negative. Negative 8. And I have 2 minus 6. Negative 4. So I have this solution set. X is equal to the solution set with negative 8 and negative 4. I don't care about the order, although on a quiz or a test, you're definitely going to see the smaller number written first. This one is the smaller number. All right, let's do another one. How do you undo something squared? Take the square root. So I just have to do plus and minus the square root for both sides, plus and minus the square root for both sides. Squaring a square root or square rooting a square, they cancel. So I'm left with x plus 13. What's the square root of 25? 5, very good. So now I'm going to break into two branches where I'm going to have x plus 13 equals negative 5, and then x plus 13 equals positive 5. How do I undo both branches? Like, how do I get x by itself? It's the same step on both. Subtract 13. On the left branch, I have negative 5 and I'm getting more negative. What's negative 5 minus 13? Negative 18. On the right, what's 5 minus 13? So I've got this solution set with negative 18 and negative 8. So this is how you do the first four problems. I will tell you that the first two, you're taking the square root of 81 and 49. Those are both perfect squares. Those are just like question 1 and question 2 on your notes. Question 3 and question 4, you are taking the square root of 50 and 45. You know how to reduce those because we just did it in the notes. So your answers for both those problems, you're not going to end up with two branches on question 3 and 4. You're going to end up with plus and minus the square root of the reduced square root. So if you're curious about those, please come up and see me and you can see my work and how I worked through those. But I'm going to give us a little break, 10 minutes for us to get started on our homework.
I know it's not here. Yes. It's in here. She goes down, I'm gonna get her to it.
And eight. You're right. The only people who get like don't put me like people it's so I mean fuck my fuck. Great things. Makes sense. I was in the back set. I was at the kid thing in the back set. It was the proof by it's only still wrong. I know on this thing. Really that was the so that one is pretty like a cool thing. It's money. I could have done that, but okay, bro. Okay, it's cool. You're dead. No. Yeah, that's the movies. It's the name of simple things. What? The what? With your plastic. Like when we can feel something. About word. Yeah, I don't need to. It's something Steve knows. I see that so many things. Something things. Most things, it's something Steve. I was thinking. The same thing. That's literally student bedroom involved. Oh, he went in first. No, I just don't know the names. I want to say went to the house once. Some guy, I mean, there's like, hey, people that sell us, and then it's like this. Wow. But then we get other plastic places. Every legit oh, you're going to
Hey, Christian.
Just going to the notes. This. Yeah, let me get to the back. I'll be saying, I'll do feet on the but I'm going to feet. Okay, I imagine now is this stupid house. That's what you. Why not? Murder. I just said I'm not even gonna question you guys. It's friends of the house and since, you know, where's the money? You got me. You got my little line, please. Honestly, I've seen first and I've seen most of the second one. I've not seen yet. It's very what do you mean you've seen most the second one? You don't forget to watch the rest. I don't know what they in the first one.
Hello.
You got correct.
Thank you.
What have you got for a kid?
You can sit wherever you want to, grab the notes and the homework. They're on this front table.
Okay, that's it's the spell. I think these lab. Six. Oh, yeah, yeah, 22. Strip of them. Yeah. It's fixed. Work. Will be six. There's none. You know I did. Must be no, I did none. Because 9 times 2 is 18. Yeah. So the 3 square root of 2. 3 out of square root of 2. Yeah, it's on the answer.
Oh, yeah. I forgot. There's an answer key on the back. Yeah, I forgot about that. I made a little answer key for you.
What? So remember what? I know. But he's even on the phone. We want to go talking. The answer to explode. It's something she said last. There's the end. I'm gonna go to the age. I'm doing it for the entire time. Yeah, it's like they spent the, you know, on your feet and learned the states time. So what we did something like sort of listening. That would be very I've been working at flip flops, the work with them in the after. So I don't even know, okay, low grass, it's interesting, very like in between them. You're off. Even schools. It's like nice. If we had a thing like that, or even with a record for town hall, for the regular game, almost anymore. But that's nothing. It requires of last year. Oh, that's terrible. Something on the ball. Phone ball, yeah, phone baseball, right? You can throw real. So better throw that, like, you know, please. I don't know, you go to the list. But if you were to miss, and it were to like bounce off, hit someone, that's a ball card. And I think last year, it was like 18. It was like 23, from 20 to the end is one of the beginning of the year to the. Eli won, right? Okay, that's not too bad. It's definitely not great, it's not bad, but he's also stopped counting. If he got one, he doesn't, it's probably stop somebody's shoulder. That shouldn't be, that should be a ball crying. Oh, why did it hold the ball? Because he hit no, every time it's phone baseball. Every time ball. Every time Harry Buffett takes ball. He does. So it does when he's something to see. I'm very sure you have to admit because y'all are doing it. And y'all are like, it's terrific. Because like every single time he does, like when you get somebody with it, y'all are like, oh. That's right. No. No. It's that is like, as long as it's silliness. Like the master video. Oh yeah. Yes. This weekend. It is. I didn't do the first reading shows. And that's it. And I think there's go. That's it. Wait, do you guys have? You like it? Get it? Okay. You like that? That could be your recipe. I'm sorry, we're not bright. No, a little bright. It's a little bright. Little bright. He's one of the best rappers in this one. No, I actually think that was West than being a captain from. I don't know why. No West.
Alrighty, we're gonna play a little bit of Family Feud.
Okay. It's not carbonated, it's first of all, it's such a pocket and.
Name something you hope is as beautiful on the inside as out.
Person. That was my first black person.
We'll play one more round. Notes. Name something that gets dumped.
Liquids. The best thing you kept out of it. All right.
All right.
The fact that I guess it was the third answer, and then liquid was the second answer.
All right. The notes. The next section that we're gonna do when you can't factor, well, actually, even if you can factor, you can complete the square to solve every time. So there's a couple of factoring methods that we'll use. Judah, put your phone away. There's a couple of factoring methods that we're gonna learn about that you can use all the time. So completing the square is one of them. So that's what goes in the first blank. Complete the square. Complete the square. So these are the steps, and you already know these steps because we've already learned how to complete the square. We didn't learn how to complete the square to solve. We learned how to complete the square to write in vertex form, but some of the steps are the same. We want to make sure that the problem is set equal to 0. We want to rewrite in the form of, we've got ax squared plus bx plus blank equals, actually, we need to add something to the top line. Set equal to 0 and move the constant. So remember the constant is C. We need to move the constant to the other side. So this step already has the constant moved. We move the constant and we actually write 2 lines. We write this next line where it's x squared equals, and the sign that's my B term determines this sign inside my parentheses. So we get everything set to complete the square. We're going to add b divided by 2 squared to both sides. B divided by 2 is what's in parentheses, and it's what will stay in parentheses. Then we work our way up and around. So we'll do b divided by 2 squared, and that's what will go on the 2 blanks. Sherry Permenter. Sure, no problem. Bye. Alyssa, when I'm done with this problem, then you go to the front to pick up your ID. Then we're going to factor, which is actually this part right here. And then we're going to use square roots like question 1 and 2 to solve. So let's do this. The first problem, it is not set equal to 0. It needs to be set equal to 0 so that we can solve. So first step, I'm going to set it equal to 0, and I'm going to move that constant. So I'm going to add 4 to the other side. I'm going to rewrite my problem, scooting it over a little bit to the left so I have enough room to work. I'll have x squared plus 6x plus blank equals 4 plus blank. It's always plus blank. And then my next line is where it's factored. And my sign is going to be positive because this is positive. So when I do my next problem, in parentheses, it'll be negative. Off to the side, I'm going to complete the square. So I'm going to have b divided by 2 squared. 6 divided by 2 squared. What's 6 divided by 2? That what's in parentheses stays in parentheses. So I put 3. And then I work my way up. So what is 3 squared? 9. And I add that to both sides. Plus 9, plus 9. What is 4 plus 9? 13. At this point, this is a problem just like question 1 and 2, where I have parentheses squared equals a number. Well, to get x by itself, I need to undo this that is squared. So I'm going to take the square root of both sides. So I'm going to do plus and minus square root on this side, plus and minus square root on this side. So on the left, square rooting a square will cancel. So I'm left with x plus 3 on the left. So before, we would move the 13 back because we were trying to get in factored in vertex form. We're not trying to do that anymore. We're trying to get x by itself. And so we've got plus and minus the square root of 13. Does the square root of 13, is that a perfect square?
Okay.
Is there a perfect square that will divide into it? No. So it is just plus and minus the square root of 13. And I'm going to tell you a little secret. When the square root doesn't reduce, they're actually a little bit easier problems because you don't have to do as much work. Like I don't have to split it into 2 branches because I can't reduce the square root of 13. So all I do is move the 3 over and it's going to go in front of the square root. I'm going to subtract 3 and I rewrite it. So I'm actually ready to make my solution set. My solution set is going to be -3 plus and minus the square root of 13. I didn't have to make 2 branches to solve. So this is like question 3 and 4 on your homework. So this is completing the square to solve. My next problem, it's going to solve the same way. I'm going to complete the square. And one reason I might complete the square is because I can't think of something that I can multiply to make 6 that I could add or subtract to make -10. There's nothing that multiplies to make 6 that add or subtracts to make 10. So I'm going to complete the square. It's already equal to 0. So all I need to do is subtract 6 and start rewriting it so I can complete the square and factor. So I get x squared minus 10x plus blank equals -6 plus blank. And then my next line where I'm factored, x minus, because the 10 is negative. Now I'm ready to complete the square to factor. So I have b. What is b? 10. So I have 10 divided by 2 squared. What's in parentheses stays in parentheses. So what's 10 divided by 2? 5. What's 5 squared? 25. What you add to one side, you have to add to the other. What's 25 minus 6? 19. All right, to solve this problem, I need to undo the square piece so that I can get x by itself. So I'm going to take the square root of both sides, plus and minus square root, and this will cancel, plus and minus the square root of 19. Does the square root of 19 reduce? No, so it just stays plus and minus square root 19. And like I said, these are actually a little easier to solve because I have less work to do. X minus 5. To get x by itself, all I need to do is bring over the minus 5 by adding. I'm going to add 5 in front of the square root. So my solution set is 5 plus and minus the square root of 19. So we're going to pause this at this point. You can start working on questions 5 through 8. In fact, 5 through 12 is completing the square. It isn't until you get to question 11 and 12 that you actually have imaginary answers, so you can get started on those. Please make good use of your time. Melissa, please put your Chromebook away. We're working on notes and homework right now. And please remember to utilize your solutions on the back. You can start marking them off.
You're drawing. Is the one for me. The same as his limits, the what was tells. My dog, I'm done with that, she's gonna be. Okay, girls, I'm the oldest, so it's family, but many of the type of family are weird, okay, it's hard to leave, sometimes. It's those means, I didn't say work, so sometimes are like, just a little. You know. I personally always said we need that, we don't know, it's cousins that have kids, they are so cousins. What is that? Is it? They said everything's going on there, they are needs. How's that? Yeah. A lot. So, you know, cousins. Plus, it's seen in case of slide. How's it then? Yeah. There's a boat. Yeah, it's long, it's easy to clean. One of them, the other one, I'm thinking other one, yeah, with. Oh no, he's so here, listen, the literally feature, like, you know. And like the older one, I don't blame you. What's wrong with this? Sister's house. So first they just. I think sandals you get that shows. I don't like. But we don't. I'm not. I'm not part of your services. Yes. One time. One time. Sorry. Yes. There's literally no reason for any of the farms on the topics, even Jake, some of those. We have this way. You guys go off there and then go out and have that. It's not even staying on the bus. You just. Yeah, no, it's not the take that, yes, but it's extra buses, so you use it. Yeah. We don't. If no one else is right. They bought this as the.
I will be that on, so we get.
So it's silly. Book a bag for the kids.
Oh.
What's wrong with farms? There's somebody inside with an air conditioning. I was. I still know it's best to do everything. Believe. Hold on, we're going to pass, so I have some different meters that. I need everything. I don't think it's that so. And you always stop. It's the way. I'm not. Like. So. What else you should be doing with this fan? It is so fun. Just wild. Yeah. Yeah, you both have the answer. There's a way to simplify this. No. Oh, what? Yeah. Even waste from the 16 now. It can go to me. It's weird. Thanks for putting that out. Yes. I was like, might be just need someone to say, that was a big. Of course. Okay. I mean, y'all were just. And then you could stay in this channel when you have it. It's just a little bit. I know both. I'm there. Wow. Just. Your parents and all of it. I can't think. Yeah. You need to find. No, I think that was this year. It's funny. Stay home, it also is a parent. Every day. Few hours. Yeah, for the ones that do that. So down next to run the cases against them. I think from this day. I don't leave off much. States would be set for that deliver performance on the that. So it's basically the estimate. We don't have carbon budget. And we can have his name's pay with stuff falls into it. There was one like five that reachable to last more area.
We're gonna finish our game. Name something that seems to sleep a lot.
Well. No, that people. Bear.
Bear or panda.
That was bear. Dog. Dog. No. Yeah, we were actually paying, so we had lost a single bit of 4 months. But that's when we were. Good money, good money, good money.
Name something people search for in the dark.
Well, Ease. Glasses, yeah, that's a good one.
Name something you'd hate to discover you'd been sitting on.
Damn.
Gum. Slime. Glue.
I think gum's a good one. Name a body part that often gets broken. Arm, leg, I think either one of those. Name a place where a person might be a no-show.
Job.
Name a place a hiker hates to discover that he forgot to pack in his backpack. Name something a hiker. Water.
Flashlight.
Oh, wait.
We got 5 points for that. Plus water.
We might not get it. We might get it.
That's embarrassing.
Oh, we did it. 704? Yeah, we did it. Second place.
We did it. We did it.
Yeah, go. Did it.
Oh,
It's that we're in second place. That would be Jason. Jason's in fourth. Oh, I didn't know. I didn't get this stuff. I just didn't remember what Why would you be searching? Well, it makes sense. No, yeah, but like,
We're on last 5 points, but why did I guess that?
It's like 1990, totally sounded. He said.
We've only got a couple more problems. So question number 6. This is similar to what we've been doing. So we're going to solve using square roots. There's nothing that can multiply to give you 8 that can add to give you 4. So we're going to solve using square roots. First thing I'm going to do is set this problem equal to 0 and move over the 8. So I'm going to subtract 8. From here, I'm going to rewrite the next 2 lines. I'm going to have, nope, not that. X squared plus 4x, always plus blank, equals negative 8 plus blank. The next line is factored. And since the b term is positive, in the parentheses will be positive. Off to the side, I'm going to complete the square. So I'm going to have b divided by 2 squared. What is the b term? 4 divided by 2 squared. What's in parentheses will stay in parentheses. What's 4 divided by 2? 2. What is 2 squared? 4. So I'm going to add 4 to both sides. What's negative 8 plus 4? Negative 4. All right, to solve this one using a square root, I'm going to have to take the plus and minus, the square root of both sides. So anytime you're square rooting something squared, they will cancel their inverse operations. And so on the left, I am left with x plus 2. On the right, this is the first time we've done the square root of a negative number when we're completing the square to solve. So for this one, what is the square root of negative 4? 2i. So I have plus and minus 2i. And so I am going to bring over the 2. Real numbers cannot be added or subtracted to imaginary numbers, so they're going to stay separate. So when I rewrite this, I have the solution set. X is equal to negative 2 plus and minus 2i. So again, you cannot put these together and you have 2 separate parts. So this is considered the real part and this is considered imaginary. They cannot be put together. They have to stay separate. And that is my answer. I have one last section. So one last section, you will have to memorize this chart or this wheel to help you. There is this chart and it starts with I to the first power. So you'll see that it doesn't have any power, so it's to the first power. And then it goes around clockwise. So I to the first, second, third, and fourth. And the behavior continues, keep going around. So this would be the same, you'd get the same answer for I to the fifth, I to the sixth, seventh, eighth, ninth, 10th, 11th. So that's how we're going to get all the way up to I to the 32 power. So you just keep going around. But we have to know what each of them equal. So I, starting with the top, I is just I. It doesn't change. It's just I. I is I. Okay, I squared. It actually turns into negative 1. And so if you can remember those two things, figuring out the other side or what's across from them is just the opposite. So if this is positive I, this one turns into negative I. If this is negative 1, then this one is positive 1. So I'm going to show you how this works. I to the 7th, I'm going to count until I get to 7, starting with 1. 1, 2, 3, 4, 5, 6, 7. I to the 7th equals negative I. Equals negative I. There's not really any math involved, it's just counting. I to the 14th. Well, I'm going to be smart. I already stopped at negative I is where I to the 7th is. So I'm going to start here because I know that this is the same place as I to the 7th. 8, 9, 10, 11, 12, 13, 14. So I to the 14th is going to be negative 1. All right, again, I'm going to be smart. I'm not going to start all the way over at 1. 14 is a lot closer to 32. So I'm going to start right here. I know that this is I to the 14th. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I to the 32th power is 1. So on a quiz, you have to remember how to fill this chart out. And they go together, I and negative I across from each other. -1 and +1 across from each other. So however you want to memorize that chart, and then you just count. That's it. So that's the last bit of notes. Please be productive. You've got 25 minutes to finish up your homework. Make sure you use the answer key.